Uh, I'll be talking a little bit about a few open data sets and how to access those automatically into your R spatial or R workflows using APIs directly natively within R. So if you are someone who is a researcher or a data nerd or anything else, and you love using spatial data, or you work with a lot of social data and you're interested in using the IPUMS and HGIS data, and you work with R, or you're interested in building your R toolkit, this is a great webinar for you. So I have a couple links here, and there's also a link tree that I shared in the chat. That's the first link, and it has also provided a link to the iGuide platform. So the link tree has quite a few links, including at the top a link to create an NHJS account and IPUMS or IPUMS NHJS account and API key. If you want to follow along and code along with that component, the extracting NHJS data, you will need to, yeah, I'll share it again. You will need to create a account. So maybe while I'm introducing the webinar, to get started with that. In addition, you'll also need to log into the iGuide platform if you've never done that before. I recommend testing that out now, and if possible, use a institutional EDU email. And if you run into any issues with that, our iGuide team is in chat and can help you out with that. In addition to NHGS, I'm also going to be going over OpenStreetMap and Natural Earth, which are two excellent open source spatial data sources that I use often. And those do not need keys, so we'll just go right into those. You don't need to worry about any prep. Okay, so as Anna mentioned, I've done many of these workshops for iGuide before. And they kind of center around this set of notebooks that I've been developing called the R Spatial, that I call the R Spatial Notebook series. And kind of my goal with them is to sort of create a series of notebooks that can be like a template or an example of multiple components in the process of creating a reproducible workflow in R for your data integration, data analysis, and mapping, and everything that may be involved in a social science project that involves a lot of spatial data. So if you're used to working with population data, spatial data, environmental data, and you're interested in creating reproducible workflows in R, some of these notebooks may be of interest to you. If you want to check out all of the notebooks that are available, there's a link in the link tree. Not only the ones that I'll be going over today, but I think we're up to maybe like about 30, and I have more coming in the future. So keep an eye out for that. There is also a link to sign up for my mailing list where I will announce any new workflow or any new workshops, as well as new notebooks. And these are all also open source. So if you want to access them either on the iGuide platform and modify them to your needs, or if you want to download them directly from my GitHub, that is all absolutely fine, and you can tailor them to your specific needs. Oh, Anna, do I have the wrong, do I have the wrong do I have the old platform link in my link
Yeah,
tree?
I think so,
Oh, okay.
but that's okay. Like
Do
I think
not,
I pasted the new link and yeah, from there you can click on
yeah.
Jupyter Hub and it should go.
Okay. Yeah, sorry about that. I forgot to test that one. I remember it's updated recently.
Yeah.
Thank you. Yeah, okay. So if you go to the oh no. If you use the links in my page that has all of the notebooks, it should be the correct links, but it looks like the one in my link tree is incorrect. Okay, so yeah, as I said, a little overview. You can access all the notebooks using this link in red at the bottom, or there is also a link in the link tree. I also focus a lot on specifically the IPUMS repository of data from ISRD at the University of Minnesota. And if you're not familiar with IPUMS, it's a fantastic source of population and social data which includes harmonized versions of US Census data, ACS data, lots of other US federal data sources, as well as international population data. So if you are a population or social scientist, or you're interested in using census data for your projects, that is a fantastic source if you're not already familiar with it. Okay, so again, here's the reminders, and we'll get started with the live code demonstration. So what I'm going to do today is we're going to go through a couple of notebooks. I'm going to start with a few of the introductory notebooks from the first chapter of my notebook series. If you, if you take a look at my website here, just to refresh because I've updated it. Yep. If you take a look at my website here with the different chapters, you can see all the notebooks are kind of organized by type. So we're going to start with a couple of these initial overview notebooks, and then we'll dive into exporting or importing data directly from those sources into your workflows. I will be skipping over a little bit of additional stuff, including understanding the SF data format, working with CRS, things like that, that are sort of fundamentals of working with spatial data, just in the interest of time. So if some of the things I talk about are things you're not familiar with, I especially related to spatial data and working with spatial data in R, I suggest or recommend that you go back and take a look at these notebooks after the workshop, and then go back and work with your data after getting a little bit of background information there. Okay, is there any questions before we get started with the demos? Let me just make sure these are working correctly. Yeah, okay, good. All right. Okay, so the first one I'm going to start with is we're going to go through chapters 1.1, 1.2, and 1.3. So if you click on any of these links, it will take you to a page that looks like this. And this is just the kind of landing page for one of the knowledge elements that is included in the iGuide platform. So knowledge elements can be something like a notebook like I have here, or a data set. And they're just user contributed by the IPUMS community and can be directly opened in the iGuide platform by clicking on this Run This Notebook link. So we'll start with our first notebook. Click on Run This Notebook. I've already got one open here, so I'm confusing my browser, but that's okay. And it will take you to this interface. If you haven't logged in, it'll first take you to a login screen. So you go through that login process, and then you'll be taken to this interface where you can work with your notebooks. So you can see I have a lot of other things that I've been working with within the iGuide platform, but if you're new, you'll just have the first notebook that you have opened. For the first few notebooks, if you want to just review them here, there's actually no code. I'll just be going quickly over the data sources. Those are all the chapter 1 notebooks. Don't actually have code, so you do not need to work with them in the platform. But we'll also be doing chapter 3.2, 4.1, and 4.2, which do have code, and we'll be able to work with them directly. I was working with them earlier. Work with them directly in here. Okay, so a couple of the data sources that we're going to talk about. So the first data source is the IPUMS, the IPUM Integrated Public Use Microdata Set Series. That is a series of data sets that are hosted by ISRD, which is the Institute for Social Research and Data Innovation at the University of Minnesota. And as I mentioned, there's a lot of different US and international data sources available in this repository, including US Census data, CPS data, health and education data, as well as international data. We're going to focus on this data set, the National Historic Geographic Information System, or NHGIS, which is the spatial or repository of spatial data within IPUMS that has basically census, data within GIS boundary files. The rest of these data sets are all tabular, but this specific data set is a spatial data set. So if you're used to using census data or ACS data for the United States at like state level, census level, census tract level, any geographic level, that is all going to be available here. And we will be able to use the IPUMS API to directly import that into our workflows and use those directly in R. The package that we're going to be using to work with that data is the IPUMS R package, or IPUMS R package, and it's specifically designed for loading and managing and IPUMS data, including the NHDS data as well as other data sources. For the most part, you can access most of the data sources within IPUMS directly from the API. I think there's a few that, a few that are not currently available. And if you do go back and are interested in exploring any of the other data sources within IPUMS, note that you will need to create a different API key for each of the repositories. So today we're going to do NHGIS, so you need an NHGIS key. But if you want to work in the future with any of these other ones, you'll need a different API key. All right, so next, we're going to jump right into I think what we'll do instead of looking at the other data sources, since we just talked about IPUMS, we'll jump right into running the IPUMS data extract process. Goodness. And I'm just going to reload this. So that'll be notebook 3.2. You can see that I also have, if you're interested in the USA data source, which is the tabular version of USA data, there's also a notebook for that. And I'll be having additional notebooks for the IPUMS data in the future. Okay, so as I mentioned, NHGIS is a harmonized data source that includes information from the Decennial Census and American Community Survey, as well as a few other historical US Census data sources. This is a little bit of additional information about NHGIS. If you're interested, I recommend you take a look at that after the presentation. I'm not going to go in detail about it here, but essentially it's just going to be the US Census data, but with geographic information. So we can download, would essentially be like a shapefile with census data attached to it. All right, so the steps of this notebook, we're going to first import our packages, get our NHGIS key, our API key set up, and then we'll go through the process. So I accidentally included my API key in here. It's okay. All right, so at the beginning of each of my notebooks within this series, there's information on all of the packages that I'll be using. So if you're not familiar or less familiar with R, this is sort of a little overview that can help you understand exactly what's going on with all the different functions and packages that are in use in this particular notebook. If you are running this on your local machine, you can uncomment. If you download this and run it on your local machine, you can uncomment and run this installation line. But if you're running it within the iGuide platform, these will all be installed already, so you do not need to run this installation. I also forgot that if you are on the iGuide platform, we need to make sure we're on the right kernel. So if you go up here to the top right of your interface for the notebook and click on this little R. We're currently in the standard R kernel, but we're going to switch to this iGuide EWD R kernel, which I have pre-populated with all, or have had all of the functions that or packages that we need already installed. We'll install these packages. It will maybe give us little warnings. Don't worry about that. then we will input your API key. I'm going to scroll past this since I have input mine. So run matplock to input your API key if you've created a API key with your NHGIS account. If you're created an account with a different IPUMS data set, just note that you will need specifically your NHGIS API key for this process, for this particular notebook. All right, so the first step we'll do is first review the data sets that are available in the NHGIS repository. So what this step is going to do is we're going to get all of the metadata for the time series tables. So this is the, I'm going to return all the metadata for all the available time series tables in the NHGIS. One more minute. All right, I apologize for that. I just needed to reload my API key really quickly just to get that set up. All right, so I loaded my API key and I ran this get metadata, that's a command line, and it's going to return this table of metadata. So this is giving me, this is just the top few lines, but this is giving me information on all of the data that's available in the NHGIS IPUMS. So you can see that there's a lot more rows. So there's a lot more data sets. And within each of these, this is a table, so it's kind of an embedded multi-level data set. So it's, or data frame. So with which in each of these lists, or which in each of these rows, there's an additional list of more data. So there's a lot of data available here from the NHGIS repo. So from this preview, we're going to filter that set of metadata that we downloaded or extracted from the database. So what we're going to do, for example, right here, I have a little filter command or a little filter chunk of code that I'm going to take only the data sets that are about total population. So we'll do that, and we have a few data sets available. So we're going to dive a little bit more into those. So let's take a look at the additional metadata for the specific time series table CL8. And we can see that the information here shows us that there, this particular data set, CL8, is a total population standardized to 2010 geographies. And has multiple different years available. This is for the decennial censuses for the United States, and is available at multiple different geographies. So you can kind of get the idea that we have all of these available data sets, and then for a specific data set, you also have availability at a specific year or time frame or series of years if it's the ACS, as well as different geographies. So that's going to be the spatial geographies that are downloaded with the data when we download them. Yep. So yeah, the information we got its total population, standardized to 2010 geographies, available for these 4 years and at many geography levels. Okay. So this is a little bit of a complicated chunk of code, but what I have here is just a way to really cleanly take a look, cleanly take a look at sort of the metadata for multiple data sets at once. So this is, instead of this kind of simplified table, we have a little bit more complicated table with the information for the total population data sets within the IPUMS and NHGIS repo. So this is all just kind of in the exploration process to see what's available, and it's for you as the user, or I've set this workflow for you as the user to get an idea of what's there and then be able to identify what you're interested in. So the next thing we'll do is we're going to select a data set. We say, okay, for my project, I'm interested in this decennial census, and maybe I want it at one of these smaller geographies. So I'm going to select CLA. So I'm just going to save this selection in a variable to start, in an object to use later. So take a look again at our metadata. We looked at this earlier, but just reviewing it. I like to do a lot of repeating of the same processes just to kind of make sure things are working correctly. Okay, so we've selected our data and now we are ready to extract it using the API. So there's going to be two steps to this if we're working with review and extract the geography shapefile and review and extract the associated tabular data and then combine them. So the next step then after selecting our tabular data, which we did with selecting that CL8 data set, we're going to take a look at the metadata for the geographies and look at what's available. So we already learned that we have all these multiple different geographies available for our specific tabular data set that we're interested in. And let's say for my project, I want this data at the county level. So I'm just going to save that as an object. You can also just refer directly to these keys, but you'll need to pass the specific key to indicate what geography you're interested in. And that's going to be passed to our API call. All right. So the next thing then we're going to do, since we've decided we want data at the county level, is to take a look at the metadata for the shapefiles within the NHGIS repository and then select a specific set of shapefiles. So this is also a little bit of a complicated step here, but what I'm essentially doing is I'm saying, let me get all the metadata about the shapefiles from NHGIS, filter that by a specific year, and my selection geography, which you remember I set as county, and the geographic level. So it gives me a list of 5 available data sets that are relevant to this particular search. So they're all at the 2010 level, and I selected that because if you remember, the CLA data set is harmonized to 2010, which means that that data is harmonized to 2010 geographies, and are all relevant to the specific search. So from these, we can select a geography, set of shapefiles that we're interested in. And for this particular project or this example, I'm going to select this US County 2010 TL 2010, this first one. So I'm going to also just save that key, that name in an object so I can use it in my extraction. All right, so now we have all the things that we need for our data extraction. We have the selection data table that we wanted, which is the CL8. That's the one, or that's the table that has all of our population data in it. So that we're going to specify right here. We have the geographic level that we're interested in, which is county. We know that our selection data CL8 is available at county. So we have that here. And then we have the shapefile selection that we wanted, which is this one. So we already know that that is going to be a shapefile that fits this data that we're downloading. So we set up 2 parts of this extraction. This TST times series table specification has the selection data set and the geography, and then the shapefile is our shapefile. And this is an optional description if you want to include that as well. And that all goes into this define extract NHGIS command. Okay. Oh, I forgot to run this line. There we
Yeah.
go. All right, I forgot to run that line. So, all right, now we're working again. So we've set up the extraction, and I'm going to take a look at our extraction metadata. Yep, looks good, everything we want. And now we're going to go through and submit it. So this is going to go through 4 steps of submit the data API query, wait for it to complete, and when it is ready, we're going to download it into this file path object. So this is where if you haven't imported or added a API key, or if you haven't set up an account, this is the step where you're not going to be able to run any further because you need your API key set as a global variable in your workspace for this to run. Okay, so we've got our 2 data files available. The 2 that we have here from our file path, we'll extract those as dat and ship. So that's going to be our tabular data, and that's going to be our shape file. I'm going to take a quick look at that. So we have 16 variables for all of the about 3,200 counties in the US. Take a little quick look at what that data looks like. This is the first few lines. So we can see we have all this information and attached to spatial county data. There's all our data sets. The shape file also has information on all of the 3,200 counties. So we're going to merge these 2. Here's our tabular data. Here's our shape file data using the similar GIS join key for the 2. Merge those into a new object called dat ship. Are we doing on time? And the combined version will have all of that tabular data, and then also, oops, this final column here has the geography. So you can see that we have all of our tabular data attached to the geography. If you're not familiar with an SF object, this is an SF object, and essentially it's a kind of like a data frame in R, but also has this extra column that has the metadata that allows it to be mapped and be spatial data. So we are all set. We have the data in our workspace. If we wanted to just continue to work with it and map it and analyze things with it, we could do that within our workspace, or we can save the data and have that available locally for us. And there's the steps here. I'm not going to go through that to save the data, but the point of this is just giving you a workflow for both identifying what data that you want to download from the NHGS repository, as well as downloading that data. If you have a workflow in your research or data analysis process that you need to slightly tweak or re-download the same data rapidly, this is a really nice way using a programmatic, accessing the data programmatically. That's a little bit cleaner than going in and using the online interface within IPUMS to re-download your data extraction. So for example, if I wanted to redo this whole thing, but do it at the state level instead of the county level, I could really easily just tweak my code and redo it. All right, so that was kind of the first part. Are there any questions, but specifically the NHJS data download process? Okay. So the next 2, data sets that we're going to be exploring are Natural Earth and OSM. And I have these just available here, but if you need to access those, you can go back to my landing page, or you can search for them within the IPUMS directory, or take a look at my set of contributions. They're all in here. Okay, so if you're not familiar with Natural Earth and you use spatial data or you do spatial workflows, I highly recommend getting to know Natural Earth. It is a online repository of open data that has a lot of physical and cultural geographic data files. So if you're looking for state or country boundaries, state boundaries, different administrative boundaries for the Earth, looking for um, spatial data for rivers or uh, populated places or coastlines, this is a fantastic source. The data is high quality and it is very well organized, and there's a lot of different data. So you can see we have a lot of information here. If you're interested, I recommend kind of exploring. If you're new to it, I recommend exploring the data that's available. But the few things to know about Natural Earth is that data is available at 3 different scales, so that the 10, 50, kind of indicated by 10, 50, and 100. So that's going to be the 1 to 10 meters scale, 1 to 50, and 1 to 110. And that's just 3 different levels of detail for the different files. And not everything is available at the same level. Then there's 2 major categories, cultural vector, 3 major categories: cultural vector data, which is anything that's sort of human designed, like country borders, populated places, urban borders, things like that. Physical vector data, which is anything that's naturally defined, so coastlines, oceans, etc. And then they also do have raster data, which I'm not going to go into here, but you can also explore and extract raster data from the dataset as well. Any of these, you can click on the available data and download them, which I think downloads directly as a shapefile. But we're going to talk about how to download them directly, download data directly into your R workflows using the API. Unlike the IPUMS APIs, the Natural Earth API is open, so you do not need a key. You can just start using it. All right. For accessing data from Natural Earth, we'll need these 2 R packages, Natural Earth and Natural Earth data. And as our quick overview, we're going to jump right into doing the import process. Okay, so I was in chapter 1.2. I move into chapter 4.2. Quick overview of Natural Earth. I'm sorry, this is, our Natural Earth, not Natural Earth. That's fine. Okay, so we'll need the R Natural Earth and the R Natural Earth data packages, as well as, since we're going to be working with the data in SF format, we'll need the SF data package. And I mentioned SF data formats a little bit in the previous. You've been looking for a global DEM for ages. I'm so happy. Yeah, Natural Earth is fantastic. Highly, highly recommend it. Uh, I talked a little bit about SF objects in the previous notebook. If you are unfamiliar with the concept of SF objects, it's relatively straightforward, but I highly recommend taking a look at this Introduction to SF notebook from chapter 2 on your own time if you'd like. It has a lot of, I go into a lot of detail about what this type of data set or type of data is, but it's basically a way of managing spatial data in R. Okay, so again, if you are working locally, you can install this way. And I have totally, don't worry about this. I was using this particular notebook to test if some other packages were loaded. So, oh no. Hold on. Oh. So there's a little bit of some things I was sort of messing with, but this should be fine if in the version that you're working with. Okay, so we've attached our Natural Earth and Natural Earth data packages, so it's the SF package. So first we're going to take a look at what's available in the Natural Earth repository. So we're going to very quickly list all the data. This is similar to the process we did for the NHGIS data. It's a little more simple though, because the data isn't as complicated and sort of like hierarchical as it is in NHGIS data. So we'll first take a look at the cultural data, just very easily use this any find vector data command, specify cultural. You can alternately specify physical, and it will give us a list of everything available. By default, it's going to show us everything at the 1 to 110 meter scale, the small scale. And we can change the data specific or the scale specification. So here's everything available. If you see any of these admin 1, admin 0, there's other admin levels. That's an natural Earth way of kind of specifying the physical or the cultural administration level. So admin 0 is, hopefully I'm going to get this right. Admin 0 is the most largest kind of administration. So it'd be like a country, and then admin 1 is like within a country, for example, so states, and then you can get further and further. So it's sort of a way to just designate what level of data this is. Again, if you want information on details, there's all the details here in the on the website. So we can see we've got 14 available data sets. Let's take a look at what's available at this 51 to 50 meter scale, the medium scale. So we can see we have more data is available here. Some of it's the same stuff, but just at a different scale, so a different level of detail. But we also have a few other things that aren't available at that large scale, like airports and ports. And then let's take a look at what's over at the small scale. So even more, another 80 data sets. We've got a lot of stuff here. So, and this is just the cultural group. We also have the physical group, which I'm not going to explore, as well as the raster data. So lots of great data here from Natural Earth. So this is a good thing to kind of review, because this will give you the specific kind of key that you need to use when you're doing your data extract. So for example, we're going to extract data points for airports. So we're going to use this airports key, which is straightforward, but something like this maybe isn't as straightforward. So you'll need to know exactly what you're looking for and what you want to use. All right, so we're going to go through and download a couple different sets of data from Natural Earth. There's a couple data download commands. This sort of any download is the broad catch-all for most of the data in Natural Earth. But if you want country boundaries, you can use the any countries command. And if you want any coastline data, there's a specific any coastline command. So we're going to start with using the any country and specify specifically just the United States. If I didn't specify anything, it would give me all of the countries. So give me a list of all countries. I'm just doing one because that data request for all of them is going to be pretty big. So we're just going to run that. It took 1 second and saved it to this USA boundary object. And let's just take a look at what that looks like. There we go. So this is a SF object with one feature. So we have that United States of America country boundary, and we've got some extra information here as well as the geometry. So this can be mapped. We have a geometry column, so it's an SF object, so it's a spatial data of object. So I'm going to use the base R, native base R plot function just to do a really super quick plot. If you are making plots for, your manuscript or to report or anything, I highly recommend using something more complicated like ggplot. But the reason that I use plot in these notebooks, it's a really lightweight base R command, and it gets the job done just to make sure, we have the data that we think we've downloaded. So I'll pass that USA boundary object that I've downloaded and specifically pass the geometry of the USA boundary using this stgeometry command from the SF package. So this is going to say, hey, send the spatial geometry of that object to the plot function and plot it. And it's going to give us our plot. So very simple little plot just to check, make sure we got what we wanted. And we did. It's the boundary of the United States. Excellent. So, oh, and this is a little step. I didn't do this in the previous HGIS steps, but I do have quick commands for saving the data. It's a shapefile at your local machine if you ever want to. So you can do that with any of these SF objects using STWrite and specifying it as a Esri shapefile or whatever you want it to be saved as. Okay, let's take a look at another example of data we can download from the repository. So let's take a look at some airport data. So we saw earlier that airports are available at both the, well, if you looked at the lists earlier, we could find that the airport data, which is point data, is available at the 1 to 50 meter and 1 to 10 meter scales. So let's just choose the 10-meter scale. So we're going to say, okay, within cultural data, we're going to use this catch-all any download command. And then we have to specify that we want data from the cultural repository versus physical. The type is where we put that specific key from this list of the data that we're interested in. And for this exercise, we're going to return it as an SF, which is the same type that we were working with earlier. I think it's done. Okay. I thought I submitted data. Maybe not. So metadata. Here we go. I think it's finished. Okay. Once that is finished reading, we can take a look at, let's take a look at the first few lines. So this is just the head command. We can use any commands you would typically use with a data frame with an SF object. And you can see that the data frame has a lot of, all the information on the name of the airport, type of airport, the airport code. It has a link to Wikipedia articles. So you can, if you really want to get fancy, use that to, extract information from the Wikipedia article for that particular airport. And of course, the geometry, which is the point location of the airport. So we have this list now of all these major global airports. I think there's about 400 and something in here. 41. This feels, oh, that's just the top view. There's about 400 and something major airports included in this data set. And again, we'll use this plot function with the geometry, and I did this earlier, but to just take a look and see, yeah, okay, that's the data we want. This is, it's kind of a mess, but we can tell that these point locations are kind of covering the United States, or sorry, the entire globe. There's the US and Europe and India and China, and all these major airports. Just say, okay, yeah, we have the data that we want. So this is just kind of a quick overview to show you a few different ways of extracting data from natural earth. You can also directly download data from the website, but you can import it into your R workflows and then work with it directly. So for example, if I wanted to do a workflow that said, okay, I have some analysis where I want to know the distance from the nearest major airport. I have this airport data from Natural Earth that I can directly import into my workflow and use it in my analysis. Or say, where's the nearest coastline? What time zone is the data in? The last example that I have is a time zone example, which are pretty cool. They look like this. But yeah, so it's a quick overview. Does anyone have any questions about the Natural Earth process? Natural Earth, fortunately, I think their API process and the R Natural Earth and R Natural Earth data packages, I think, are extremely easy to work with. So yeah, I absolutely love working with their data. It's very high quality. Okay, so now we'll go on to the last source, which is a fantastic. If you've never used OpenStreetMap, it's essentially there's a little bit of information here, and you can go to their website and check out what's going on. But if you have never used or heard of OpenStreetMap, it's essentially a user contributed map, similar to Google Maps, so you can see that everything that you might have in Google Map is available. If you zoom in, you have all this information on, all right, to Georgia State University, also information on the location of different types of amenities and bounding boxes and street names and everything that you might have in Google Maps. But this is totally user contributed, totally open source. And unlike Google Maps, which has a lot of restrictions on what you can extract and requires you to have a lot of logging in an API key and things like that, and restricts you and maybe charges you for the data that you extract. All this is free to extract directly from the source. So you may have worked with OpenStreetMap or seen OpenStreetMap used in applications, but we're going to talk here about how to use the Overpass API, which is OSM's API for extracting data from the OSM database directly with R to get OSM data directly into your R workflow. So a little bit of an overview on OSM, and then we're going to jump to chapter 4.2 and do a little bit of a demo. Okay, so the package that we need to access the OSM data using the Overpass API is OSM data. For this notebook, again, I'm using the SF package because we're going to be working with spatial data in the SF format. And I also I'm going to use ggplot2 to make kind of a little bit fancier map than we were making the previous notebook. So if you're not familiar with ggplot2, it's essentially a really fantastic, very powerful package for creating visualizations in R. And that includes very nice maps in R. So we'll load these packages. Oh, make sure we're in the right kernel. So if you go over here and it says R, we need to switch kernel to guide EWDR. That's going to have all of those packages installed. So if you run into a package not found, make sure you're in the right kernel. Okay, so OSM, as you can imagine, is a very detailed, complicated, well, maybe not complicated, but very detailed data source. It has a lot of different types of data in it, different types of features. And because it is user generated and user moderated by volunteers, essentially, there is a lot of variation and there's a lot of detail. So what I would suggest, if you are new to exploring OSM data, is on your own at some time, spend a little time exploring this map features page from the OSM wiki. The OSM wiki is really fantastic and very comprehensive. And this particular page has the list of all the different types of map features that are available. You can see in this contents list, there are a ton of different types of features. Those are even just the groups of features. And if you go further down, you see this table, and that's where you're going to get your key and value, your keys and values for the specific types of data that you're interested in. So you can see there's this kind of first category is aerial ways, and then there's all these different types of aerial ways, cable car, da. So if you want to go in and specifically say, hey, give me all of the gondola locations for the country of Italy or something, you can do that. One thing to also remember is because this is user-supported data, sometimes the definition of a specific, like what tags are used for a specific object can be a little bit fuzzy. So it's just somebody, an individual going in and saying, okay, I think this is a chairlift rather than a drag lift or something like that. I don't actually know what a drag lift is. Oh, I do. Never mind. For skiing. The different objects can also have multiple tags. So for example, you might have something that's like, okay, we're in the aerial category, but it is tagged as mixed lift, chairlift, and drag lift or something like that. So for the most part, it's not terrible if it's not super hard to have a query that misses things, but just keep in mind that this is a very broad and pretty comprehensive, but also somewhat fuzzy kind of system. So if you're not familiar with OSM, I suggest kind of just exploring this and just getting a sense of how the tagging systems kind of feel in a way. All right, so I talk about that a little bit here. Oh, and another thing to note about OSM is that because it is user supported and user generated and user updated, the density and specificity and like update frequency of data is a little bit different depending on the area of the world that you're looking at. So if you have data that's coming from a major metro area in a major country that uses OSM a lot, like the US or parts of Europe, you probably have very up-to-date and detailed data. But if you're working with an area that's very rural or has a lot of informal settlements, or maybe just doesn't have a lot of OSM users or people that are really interested in going and updating the data all the time, you might not have the same level of quality of data. And quality meaning, everything that is there is in the data set. We might be missing things. So that's just something to keep in mind when you're using OSM. But for the most part, I say, especially now, because OSM has been in use for a long time, it's been around for a long time, it is a fantastic source, and I think really using it anywhere in the world for anything is pretty pretty excellent, and you can trust it. All right, so what we're going to do is we're going to go through a little bit of a little exercise, a little step-by-step exercise. Similar to Natural Earth, OSM is also available at these different scales. We're going to focus on, I think, what do we do? Maybe I didn't specify the scale. But okay, when we want to set up an OSM data extraction, you need to always set up a bounding box. So the bounding box is going to be just a set of coordinates that defines the area within that you're searching. So this is a bounding box that represents kind of the boundaries of the city of Chicago. It's not going to be, the exact city kind of outline like the boundary of the city itself, but just the box that that's in. And this seems a little bit clunky, but just think of it as like, homing in on a specific area to search within. So OSM data is very good if you want to say, okay, I'm going to search in this whole area, and then maybe I want to clip using a particular polygon later or something like that. So I'm going to save this as a bounding box, as this little bbox object, and I've just looked up and Googled, usually can Google the bounding box of something, and it's pretty accurate. And then I'm going to set up my query using that bounding box. And I'm going to step by step all of the components of this API call that I'm setting up, but at the end I'll show you, you can put it all in one line. So I set up the bounding box. I use this OPQ, overpass query command, which just takes a bounding box. And a few other commands, or a few other components, but we're just at minimum need bounding box, and save that as a query. And then we're going to set up a feature query using this add OSM feature. And that's going to take this query that we set up earlier right here, and the key and value that we're particularly interested in. And I forgot to mention, for this exercise, I'm going to download highways within the city of Chicago. So those would be highway center lines. If we go back to our list here, I'm going to go down to the highway section. you can see all of our available options for highway right here. So I'm going to focus on this primary highway. It's the most important roads theoretically. And I'm also going to do another query afterwards with secondary highway. And you can see territory highway and then a couple other different types of highways and then more types of highways. Oh, these are like subcategories, special road types, link roads, roads. It goes on and on. Lots of highways. But anyway, we'll stick with primary and secondary highways. So first, I'm going to download just the primary highways. And if you want to download more than one type, you can pass a list of keys and values. But just for simplicity here, I'm going to just do one of each. So we're going to say, okay, within that bounding box, I want all the highways that are tagged as primary. And that is it. This feature query is downloaded. I'm going to use this OSM data command to convert the data into an SF object and then save it to this Chicago Highways primary object. And now that is in our, or will be in our workspace. This is exactly the same as these steps combined, but I'm just showing that if you want to do kind of a cleaner interface, you can do everything together. So say, okay, I'm going to take the bounding box, make that a query, and add the feature primary highways, and then convert it to an OSMSF and save it as that, and it'll do the exact same. All right, so let's take a look at it. So this is a SF object, and you can see it has a couple different things in here. So we've got points and lines, no polygons in this one, and it shows as a bounding box as well. So a collection of about 1,500 points, 1,400 points, and 5,000 lines. So these are going to be the lines that represent the highways. These points are the points that kind of make up the line strings. So there could be a situation where you want to use the points that make up the line strings that represent the highways, but probably you're most likely going to focus on the line strings for this one. But you can just take a look at, what comes with that data when you extract it. So now we're going to do another quick plot. We'll take our Chicago's highway primary. We're going to say I want the lines component from that object. So you can see we use this $sign to access different components of that object that we downloaded. And I'm going to extract the geometry and plot it. That's with our simple little plot. And there it is. These are the major highways from the Chicago metropolitan area. Again, just a quick simple map just to tell us, okay, yeah, we got what we think that we should get. It looks like highways and looks like, if you're familiar with the Chicago area, it's kind of the shape of Chicago. So we're going to do another round of this, exactly the same, except we're going to do secondary highways. So we're going to do another call. Take a look at that. This one is going to be like previous down there. This one is going to be much larger because there's a lot more secondary highways than there are primary highways. So it may take you a little bit of time, a little extra time to download that. And again, we can see we've got all our points and lines here. And we'll plot it. A little over time, we're almost done. We're like 2 minutes away from being done. All right, so there's our secondary highways. So yeah, just a quick overview of ways that you can pull OSM data right directly into your workflows within R. And as you can see from this very exhaustive table, there's a tremendous amount of data that you have at your access, including, restaurant data and hospitals and lakes and anything that you could find on a on OSM map or a similar Google map you can get, and you can get very easily and free from the OSM over Pass API. The last little step here, I'm going to do a little, already plotted it. I should have cleared all these, but so you can get the surprise, but I'm sorry they didn't. We're going to do a little ggplot here just to make it a little bit nicer. And so we can also plot both sets of data on the same map. So this is a very simple setup for a ggplot. You can do a lot of things with ggplots and make them very fancy and add all kinds of stuff. But I'm setting up a ggplot and adding two GeoMSF, so that's geometry with simple features objects. One is the primary highways, and I'm going to specify OSM lines similar to the way I did there. And the other ones are secondary. I'm going to color the primaries red and the secondaries gray. And then I'm also going to do this minimal theme. It's just a little bit nicer than the base ggplot theme. And then we have a map, and we can see that we've downloaded this free data from OSM, and we have information on the highways, primary and secondary highways in Chicago. And yeah, that's the end of this demo. I hope this was helpful, and I hope you got some information on a few open source data sources as well as how to access them. Again, all three of these data sources are phenomenal, and it's all free. Even though you have to create an account within IPUMS NHGS, that is still free. And then obviously Open OSM and Natural Earth are just accessible as is. So yeah, is there any questions before we leave? Yeah, Maxwell.
Hi, yeah, Kate, thank you so much for this. I learned tons. Really appreciate it. So this is just kind of a side question. Does OpenStreetMaps allow for free geocoding of addresses, kind of similar to like Google Maps API, but without having, I mean, they have a free tier, but you know.
Mm-hmm. You know what? I'm not sure. I think the Overpass API is specifically for extracting data. I want to say no, that they don't, but I'm not sure. I've actually never looked into it, so I'm sorry. That's something I think I'm sure would be a lot of information on within the OSM wiki if it's available. Because yeah, I know that geocoding is always can be costly. But yeah, I'm actually
Thanks.
not
Yeah.
sure. Yeah, I'm sorry about
Total
that. But
side question. Yeah, no worries. I appreciate
no.
it. Thank you.
Mhm. All right, well, thank everybody so much. Again, my link tree is in. Oh, Joken, thank you so much. Okay. We got a Maxwell, we got a answer from somebody in chat. Thank you. Thank you everybody for being here. I've added my link tree again if you want to check out the other notebooks or if you want to join my mailing list. And there's also more VCOs, as Anand mentioned, coming up, not just from me, but from others in the community on other topics. So please join the iGuide mailing list to get information on those upcoming VCOs. And Anna, do you have anything you want to add before we go?
I think, Kate, you covered it first. Thank you for doing this. We have, as Kate said, we have a bunch of other VCOs planned for October and November as well. And I'm sure Kate will come back and have more VCOs on this and other related topics. So please keep an eye out. Join the iGuide mailing list as well. And if you go to this page, which I just posted in the chat, that's kind of list of our future upcoming VCOs as well as like the past VCOs we have done and the recordings to that. There was a couple interest in OSM. We actually had like the OSM developer, one of the OSM developers, primary developers, talk about the science for the urban networks and how the OpenStreetMaps works. So you can find the recordings for that as well. If nothing further, thank you again, Kate, and
Thank
we'll
you.
see you all at one of the other iGuide events, including the VCS.
Again.
Thanks, everybody.
Thank
Have a
you.
good day.
Bye.